In this lesson, we'll talk about increasing and decreasing functions and the sign of the derivative. In other words, we'll see how differentiation can help us tell whether or not a function is increasing or decreasing over an interval from a to b. We will rely on what we've learned in the previous lesson, where we've discussed increasing and decreasing functions, and we've come up with two definitions for them. We have on the left a decreasing function and on the right an increasing function. The blue one and the red one. For the decreasing function on the left, we've noticed that for any x1 and x2 in the interval from a to b, if x1 is less than x2, like we've chosen here, then f of x1 will actually be greater than f of x2. In other words, the smaller the value of x, the bigger the value of the function, or the bigger the value of x, the smaller the value of the function. And this is what we call a decreasing function. On the right, we have the exact opposite. If x1 is less than x2, then we can see that f of x1 is also less than f of x2. So in other words, the bigger the value of x, the bigger the value of the function. And we call this an increasing function. Now this is what we've learned previously and the definitions that we've established. How do they connect to the derivative? Well, let's see. Let's rename our x2 x. So our definition would look like this. x1 is less than x, then we get that f of x1 is greater than f of x. x1 is less than x, this leads to x minus x1 is greater than 0. So if we subtract x1 from x, we get a positive value. F of x1 is greater than f of x, which would mean that f of x1 minus f of x is also greater than 0. And the opposite of this, f of x minus f of x1, will therefore be less than 0. Now we have here a number that is greater than 0 and a number that is less than 0. The ratio we can make out of these two will be a number that is then less than 0 because we have negative over positive. In other words, f of x minus f of x1 over x minus x1 will be less than 0. Suppose we add to this the limit when x approaches x1. The limit when x approaches x1 of f of x minus f of x1 over x minus x1 is actually the derivative of f in x1. In other words, the function being decreasing over the interval from a to b means that the sign of the derivative is minus, that the derivative is negative over the interval from a to b. So for any value of x within the interval from a to b. This is a very important result, which we will write here. F dashed of any x being negative means f is decreasing. And like I said, it's very important because it can help us to tell whether or not a function is decreasing over an interval using differentiation. We will now turn our attention to the function on the right, but for this we will create some space. And now we can repeat the process and see what kind of a result we get for the function on the right. We have x1 is less than x2. And we will again say instead of x1, we have any random value of x is less than x2, which implies for us that f of x is less than f of x2. X is less than x2 means that x minus x2 is less than 0. F of x is less than f of x2 means that f of x minus f of x2 is also less than 0. We have two negative quantities, and if we do a ratio of the two negatives, we will get a positive. So we can say now that f of x minus f of x2, which is negative, over x minus x2, which is also negative, will be positive, so it's greater than 0. Add to this again the limit when x approaches x2, and what we get is actually the derivative of f in x2. In other words, for an increasing function, the sign of the derivative will be plus, the derivative will be positive. We will erase the calculations and keep only the result, which is that if f dashed of x is positive over the interval from a to b, then that means that f is increasing. So keep in mind these two excellent results that we have, which will be very important for us when working with functions. If f dashed of x is less than 0, we have a decreasing function. If f dashed of x is greater than 0, then we have an increasing function. How exactly we use this and what will happen when functions increase and decrease during different intervals, we'll see in the following lesson where we tackle some problems. So I'll see you there.